Hi and Assalamualaikum. My name is Izan Kalisa binti Lokman. In this video, I'm going to talk about the current problem in management of domestic waste, which is grey water drainage or wastewater treatment plant. Grey water is all the wastewater generated in household or office buildings from streams without fecal contamination. Sources of grey water include sinks, showers, baths, washing machines, or dishwashers. Grey water comprises 50 to 80% of residential wastewater. Stormwater is rainwater and melted snow that runs off lawns, streets, and other land surfaces. This runoff is supposed to be absorbed by plants and soils or make its way back to ponds and streams. However, more hard surfaces such as pavement, parking lots, driveways, sidewalks, and roofs, especially in urban areas, prevent this runoff from naturally soaking into the ground and instead be stored on the land surface in ponds and puddles, evaporate, or contribute to surface runoff. Most runoff is conveyed directly to nearby streams, rivers, or other water bodies without treatment. One of the most common forms of pollution control in Malaysia is wastewater treatment. A wastewater treatment plant is a facility in which a combination of various processes including physical, chemical, and biological are used to treat industrial wastewater and remove pollutants. The first process involved at wastewater treatment plant is pre-treatment process. The pre-treatment process involves the sewage being sent through bar screen to remove large floating objects like metal can, paper, and plastic materials. Next step is the primary treatment. Primary treatment is a physical process that separates solids and liquids even more. In primary treatment process, the sewage flows through the grid chamber very slowly so that the sand, pebbles, and soil settle down at the bottom of the chamber. The sewage then flows into a settling tank where the solid waste like feces are allowed to settle down. Meanwhile, waste such as soaps, oils, and grease rise to the top of the wastewater. The waste material that settles down at the bottom is called the sludge, while the floatable material is called the scum. Every few days, scum is removed by using a skimmer and sludge is removed with a scraper. The water that is left is called the clarified water. Secondary treatment is a biological process that uses microbes to treat and remove organic materials from wastewater. The clarified water from primary treatment process is transferred into an aeration tank where air blowers bubble air, which help the aerobic bacteria to grow and feed on the organic contaminant such as food waste, feces, and other organisms. The mixture then flows from the aeration tank into the clarifier where activated sludge settles out by gravity. The activated sludge produced along with the sludge produced in the primary treatment process is transferred to the digester where it is decomposed by anaerobic bacteria. Biogas is produced in this process, which can be used as fuel or to produce electricity. The activated sludge is then left in the sand drying bed where some water in the activated sludge evaporates and the remaining water drains through the sand drying bed. Lastly, the tertiary treatment process. The leftover wastewater is treated with chlorine in order to remove the phosphorus and nitrogen compounds as well as bacteria. Chlorine tablets are added to kill the germs. This process is called chlorination. Then, this treated water is let off into water bodies. Wastewater treatment systems are designed to treat water so it can be recycled safely back into the environment. But that doesn't mean wastewater treatment plants aren't faced with their own issues. Up to 60% of the energy used by wastewater treatment plant is dedicated solely to the aeration process that controls the degradation of organic matter. To save the energy used, my recommendation for innovation of current system is using membrane aerated biofilm reactor. In this part of the video, I'm going to show why I recommend this technology. The membrane aerated biofilm reactor is deployed as a drop-in module and can be retrofitted easily into existing aeration basins without draining the tanks or interfering with the existing process. This can be used to increase biological capacity or to replace legacy aeration systems entirely. The membrane aerated biofilm reactor habitat creates an ideal environment to support a robust biofilm which absorbs and consumes carbon and nitrogen-based pollutants. Air can be fed at very low pressure through the membranes, delivering the oxygen directly to the bacteria at up to 7 times the efficiency of forced aeration. Bacteria now have the optimal conditions for growth and increased consumption of the pollutants found in the wastewater. This offers high-rate nutrient removal with up to 75% energy savings, 50% reduction in sludge, along with impressive process resilience.